Okay, I've got two stars. They have the same absolute magnitude. That means they're producing the same power. We know that A is 10 times further from the Earth. So how many times brighter would it appear than B? Well, this is the inverse square law, okay? The inverse square law goes like brightness is the luminosity divided by 4 pi d squared. Since they have the same absolute magnitude, or the same, this is to do with the luminosity, isn't it? I don't need to worry about L, so essentially that means brightness is proportional to 1 over d squared. Now, the distance ratio is 10, and therefore the brightness ratio will be 100, or probably more like 100th, since it's 1 over d squared. So how many times brighter will A appear? The answer is 0.01. What else have I got? I've got to work out the apparent magnitude of A. Okay, well, I'm going to take the this distance ratio here, and the distance ratio is 10. Now, that transfers into the magnitude scale as a difference of magnitudes of 5. We should know that. It's a fairly simple number to use, 10 and 5. So I've got lucky this time. If it had been, I'll just, for the sake of it, choose a different distance ratio. What if my distance ratio had been 1.58? What I'd need to do is work out what power of 10 that was. And that happens to be 10 to the power of 0.2. That would transfer to a magnitude difference of just 1. And you can see there that because the power is 1/5, that's from 10 to the power 1 to 10 to the power of 0.2. The difference in magnitude is 1/5. But anyway, I've got a magnitude difference of 5, and I need to work out whether A is brighter or dimmer. A is actually dimmer than B, and that tells me that I must do 0.4 plus 5, which is 1.